This tutorial is all about how to use C++ with the Godot game engine via GDNative. These things tend to change over time, so for reference, I'm using Godot 3.2. Among other things, I'll show you how to set up everything for GDNative development, how to make Godot understand your C++ classes, and how you can communicate back and forth between GDScript and C++. However, to be very clear, this is not a beginner tutorial. I will not be covering Godot basics nor teaching C++ itself. In fact, to get straight to the point, I'll be starting from a game I've already built using GDScript, which you can download from GitHub if you'd like to follow along. I'll put a link in the video description. This example was designed specifically to illustrate a performance problem from high-frequency GDScript code. But I should point out this isn't a magic bullet for fixing performance problems. If your bottleneck is graphics, for example, moving your game logic to C++ won't help. In most cases, there are simpler ways you can make your game faster, and I don't recommend this approach unless you're already an experienced programmer. That said, if you prefer working in C++, you don't need GDScript at all to make your game with Godot. One final point I want to make up front, I'm only human and I've made mistakes in tutorials before, so I encourage you to check the comments section for corrections and leave a comment if you spot any mistakes. Now let's get started. Here's what the starting project looks like. It's running okay, but there's one problem. I called the game 10,000 subs, but right now it's only got 100, and if I increase that number, we'll start to see a problem. At 10,000 submarines, the frame rate is awful. Now this could be for a few different reasons. If I had naively implemented this using 10,000 sprite nodes, the overhead from the scene hierarchy managing all those nodes would be a problem. Even if I bypassed the scene hierarchy and used the visual server directly to draw 10,000 canvas items, it might be slow because of using the GPU inefficiently. But I've already bypassed both of those problems by rendering all 10,000 submarines with a single multi-mesh instance, and I can prove it by commenting out my physics process function. As you can see, nothing is moving anymore, but the frame rate is back where it should be. I'm not using Godot's built-in physics engine, but I am running movement logic in a loop 10,000 times and doing 250,000 collision checks. That's just too much to do per frame in an inefficient language like GDScript, so I'm going to convert this script to C++. But first, for context, let's take a super brief tour of the project as is. The main scene has a few layers that are always present. When we start a level, it instances the level scene and inserts it in the middle of these layers. The level's root node has a script with the physics process function we talked about earlier. It's also responsible for placing objects randomly on ready, updating the multi-mesh with new positions for objects, and pushing or pulling the subs in response to user input. This is called from the game script. The level scene also has a HUD of sorts for showing your progress through the level. And this is also where I've placed a label to show at the end of the level. The HUD node also has a script attached, with a function for updating the progress, and it's also responsible for deciding when to show that in-text label. These functions are called from the level script. And that's pretty much it for this simple project, so let's move on to GDNative. I'm going to try to keep this part quick, but if you've already got GDNative set up, feel free to skip ahead to the next section. For the sake of time, I'll be sticking to just one possible setup on Windows, but if you know what you're doing, there are other options. To start, download Visual Studio 2019 Community Edition, and the latest version of Python. And of course, Godot if you don't have that already. For Visual Studio's setup, make sure you check the C++ development workflow. And there's still some extra junk you don't need checked by default. This is what I've settled on, but you can probably get by with even less. This install will take a while. For Python, make sure you check to add it to your path, because that'll make everything else easier. Once Python is installed, open up a command prompt and enter pip install scons. This installs sconstruct, which is Godot's preferred build system. If you're familiar with makefiles, sconstruct lets you do something similar, but with flexible Python-based scripting. Next, you'll need a copy of the Godot CPP repository from GitHub. If you want to download this as a zip, you'll need to also download the linked Godot headers repository and place its contents within the Godot headers subdirectory of Godot CPP. But if you clone the repository with Git, which I recommend, you'll get the headers automatically. Now we need to build Godot CPP, and for that I'll be using the native tools x64 command prompt shortcut that Visual Studio created. This sets up the environment for compiling, so all we have to do is go to the Godot CPP directory and run scons generate bindings equals yes, bits equals 64. This also will take a while. When it's finished, if everything works, you're theoretically ready to start developing with GDNative. But to test it, let's grab the official GDNative CPP example, also from GitHub. I like to keep my GDNative projects in sibling directories alongside Godot CPP. However, that's not the directory layout this example expects. So to fix that, I'm going to update the sconstruct file, just adding a // to these two paths. Now let's try building it. In that same native tools command prompt, I'll just go to the examples directory and run scons platform equals Windows. If that succeeds, we can now open up the project in Godot and run it. And if you see that icon moving around, everything is working and we can move on to our own project. If you skipped over the previous section, please make sure you have the official GDNative CPP example on hand, because there are a couple things that just make a lot more sense to copy and paste than to rewrite from scratch. I'll start by creating a new empty project in Visual Studio in a separate directory for my Godot project, so Godot doesn't repeatedly scan it looking for things to import. First, we'll need a CPP file to define the entry points to our native library. I'll call it nativelib. This is one of the places I suggest copying and pasting from the official GDNative CPP example, because these entry points are essentially boilerplate. The only thing you'll ever need to change here is what classes you're registering. You can register as many as you want, but you don't have to register anything that Godot doesn't need to know about. Let's come back to this when we actually have a class ready to register. First, I'm going to add a common header I want to include everywhere, just to make things easier. Everywhere we're dealing with Godot, we'll need to include Godot.hpp, and I'm also going to use the standard library and Godot namespaces everywhere. Now, if you're using Visual Studio and you want IntelliSense to understand any of this, we'll need to add a few include paths. Specifically, under Godot CPP, we're going to need Godot headers, include/core, and include/gen. And I'll change these to relative paths because I don't like my projects breaking if I move them to another hard drive or something. Now, if we got that set up right, the red squiggles should go away. Now, before we go back to nativelib, let's actually create a GDNative class. I'm going to be replacing the script on my level node, so let's call this level. In order to attach a GDNative class to a node, it needs to inherit from the Godot class for the node's type, in this case, node2D. Every GDNative class needs to inherit from either an existing Godot class or another GDNative class, but it doesn't always have to be a node type. The most basic type you can use is object. The next key step is using the Godot class macro. Its arguments are the class name you're using it in, and the class name it's inheriting from. If you ever end up inheriting from another GDNative class, you'll need to use the Godot subclass macro instead. Now, there are just two methods we need to add to have a valid GDNative class. First, a static _register methods. This is where we'll tell Godot about any properties and methods we want it to be able to access. Second, _init. This is called when an instance is created after the constructor. Now, before we get into any game-specific stuff, let's just try to get this to a point where we can sanity check that everything's working again. I'll just define these methods, but leave them empty for now. And back in nativelib, I'll register that level class. Now, before we can build this, we'll need an sconstruct file. This is another thing I'll copy from the official GDNative CPP example. I already updated this in the previous section for the relative path to my copy of the Godot CPP repository, so make sure to update these two paths for Godot CPP to match your directory structure. Next, I'll update the sources path to where my C++ code is. And finally, I'll create a bin directory under my Godot project directory, and update the target path in my sconstruct file to point there. Then I'll open up my native tools command prompt, head to the directory with my sconstruct file, and run scons platform equals Windows. Hopefully we'll see that succeed. If not, make extra sure you've got all the paths right. Unfortunately, this is the part where lots of little things could go wrong depending on your build environment, and I can't really guide you through every possibility. But once you've got that building, and you have a DLL or your platform's equivalent landing in the bin directory you created, it should be smooth sailing from here on. I'd like to take a moment to look through some of the headers because personally I found them very helpful in understanding things. Godot.hpp is a good starting point. You can see what that Godot class macro is adding for one thing. That _new method is how you'll need to construct instances of any Godot or GDNative class for things to work properly. Let's also take a peek inside core types.hpp. Here you'll find listed the headers for a lot of the core types you might be familiar with from GDScript. Variant is an interesting one to look at too. You can cast pretty much anything Godot understands to a variant and back, including your own GDNative classes. Meanwhile, all the node types, resource types, and probably some other things can be found in separate headers under the include/gen directory. There are quite a lot of them, and in most cases their interfaces are practically identical to what you get in GDScript. In fact, since our level class inherits from Node2D, we can directly call familiar methods like getNode, and there are getter and setter methods for properties like position and size. So let's get back to converting our example to GDNative. Let's add some methods to the level class to match what I had in GDScript, starting with _ready, where we'll randomly place submarines and mines, then _process, where the multi-mesh instances are updated to reflect movement done in the physics thread, then _physics process, where movement and collisions are done. Note that I'm not overriding virtual methods here. While these are special methods that get called by the engine, we still have to register them for that to happen. I'll also add in the pull method for moving the subs around. Now if I want, I can use variant for both parameters, and I can check the types of the variant and convert as needed within the function. Or I can be more explicit. Either way works. For the sake of demonstration, I'll use a mix of both. I also could have implemented _input and interpreted input events on the C++ side, but this seemed like a good place to demonstrate that your C++ methods can be called exactly the same as GDScript ones. I don't have to change anything where I'm calling this method for my game script, it just works. Although of course I do need to register it on the C++ side first. I'll do that by calling register method inside _register methods. Note that GDScript can't disambiguate overloaded methods, so if you register an overloaded method, it'll compile fine, but it's likely to crash when called. However, the registered name in quotes here doesn't have to match your actual C++ method name, so if you wanted, you could use the same name as your overloaded method in GDScript, but have it actually call a wrapper method that checks variant types to call the right overload. I'm only going to have one level in this example, but for the sake of illustration, let's expose some properties that we could use to create different levels of different difficulties, like the number of submarines, number of mines, width of the level, and just to show you how references work, the mine sprite. Most if not all resource types in Godot, including textures, inherit from a reference class, which are meant to be ref counted with a smart pointer class called ref. Registering properties works mostly the same as methods, but we'll also have to specify a default value. One potential pitfall here, Godot will not initialize your instance variables to these default values automatically. Make sure your C++ code initializes them to the same value if you want the inspector pane to be correct. Now let's get things building again for a sanity check, but to do that I'll need to create some empty definitions for these methods. And I also forgot an include I'll need for that mine texture. Now hopefully we can get this building. And once that succeeds, let's actually get this into Godot so we can confirm the properties show up. To do that, we'll need to create two resources from within the Godot editor. Right-click in the file browser, go to New Resource, and first we'll create a GDNative library. Again, I'll call it nativelib. Right now I've only got a Windows 64-bit build. Unless you're targeting the Windows Store, make sure you're looking under the Windows heading and not Windows Universal. From the Dynamic Library column, I'll browse to find my DLL, which I probably should have renamed in my sconstruct file, and this is where you would do it, but it doesn't really matter for now. Next, let's add another resource, this time a NativeScript. You'll need a NativeScript resource for every C++ class you want to be able to attach to a node or instance from GDScript. I'll call this one Level, and we'll set this one up over in the inspector pane. The class name is Level, and the library is the GDNative library resource we just created. Now let's attach this NativeScript to the Level node. Just to be clear here, every time this scene gets instanced, Godot will create a new instance of my C++ level class to go with it. Sometimes I found registered properties don't show up right away, so if that happens, just close and reopen the project, and that should fix it. Once they are showing up, let's fill them in. I've already written all of this logic in GDScript, so rather than redo it from scratch, I'm going to copy and paste and try to translate line by line. A lot of this will be straightforward and mechanical, but I'll try to call out anything non-obvious as I go. First, let's bring over the constants. Now immediately we have a problem because we can't load a scene into a constant in C++, so this will become an instance variable instead. I'll come back to that after fixing the rest of these. Now let's deal with that explosion scene. Like textures, packed scenes are resources. While I'm here, let's also declare some resources for the multi-meshes. And let's copy some more variables from the GDScript. The displacement map will be another resource, an image this time, which is extracted from a texture. I'll be setting it on ready, along with the displacement map width. For my list of subs and mines, I'll be using a standard library vector instead of a Godot array. We'll also save a reference to the HUD node. And lastly, to use Godot's random number generation, I'll need an instance of the random number generator. I'll need a few extra includes for these. And lastly, I'll need a C++ equivalent of my OceanObject class, which I'll make into a struct. And I forgot to include vector. Now I have some setup to do in the ready method. As I mentioned before, you need to instantiate Godot classes with _new. Next I'll get a reference to the HUD node. To load textures and scenes, I'll need to use Godot's resource loader. Let's go ahead and add a few missing includes. Now I'll use the resource loader to get my displacement map. In order to access pixel data, we'll need to get an image resource from the texture using getData, and we'll also need to lock it before reading. And I'll also store the width of the image here. For the explosion scene, I'll simply load it with the resource loader. The rest of the ready function can be adapted from the GDScript. However, the shorthand for getting child nodes doesn't work in C++. And I can't access this multi-mesh property directly like this either. Instead, I'll call a getter method. Now let's continue adapting the code. The end property on rect2 isn't available here, so we'll calculate that ourselves. I'll do a bit of copy-paste here to save some time. And of course there's bound to be a typo somewhere, and it looks like a copy-paste error as well. Next, let's adapt the process function. Next, the big one, physics process. Unfortunately, Visual Studio's attempts to helpfully indent for me are working against me in this case. Here I'm handling the movement behavior for a sub that's been destroyed. It falls to the ocean floor and then continues to move left. A lot of this is a product of trial and error, trying to make the movement seem reasonable, but of course it's not perfect. Here I'm sampling displacement map, so I can make the subs appear to be pushed around by the currents in the ocean. After updating positions, I confine the subs to a certain area, and make them bounce off the sides to prevent you from just sliding them along the bottom or top to avoid any mines that aren't at the extremes. The mine movement is a lot more straightforward. When it's destroyed, it's moved off the screen and then never moved again, because I'm not bothering to ever reduce the instance count on my multi-mesh. When a collision occurs, I'll instance the explosion scene. Instance returns a node pointer, but you can cast it to another type if you know what the root node is. And actually just spotted something. I don't need to continue this loop after the mine's been destroyed. Now, after determining if the mine will be triggered, I'm doing a second pass to determine which subs are within the explosion range. Now this will be our first time calling a GDScript function from C++. It's done with the call method, and passing the function name as a string. And this is where I move the mine off the screen. And now I'm calling a GDScript method with an argument. Now call is a variadic function, so you can specify multiple arguments as needed. However, I've had mixed results with this. Sometimes it just doesn't work the way I expect, and I haven't figured out a pattern to it. So instead, when I have multiple arguments, I prefer to use call v, which takes an array of parameters instead. Although there's no need to do that here. Last up, we've got the pull method. Just to show you how, let's assert that this variant is the type we expect before converting it. And that may be it. Let's see if I forgot anything. And it looks like I've got a couple of issues with my clamp call here. Clamp isn't in the version of the C++ standard that I'm using, so I need to add another compiler flag in my sconstruct file. But I also forgot to make this 0 a float. Now it's building, at least. Let's see if it works. And there we have it. I've got all 10,000 submarines moving, and the frame rate is good. So just a few more things I want to mention that didn't come up earlier. First off, if you're on Windows, there are a couple more compiler options you might want to add to your debug target to make debugging easier. And to generate a PDB, we're going to have to add some link flags. I'm placing my PDB in the same directory with my DLL. I should also mention that when you're building with scons, debug is the default target. If you want a release build, just add target equals release to your command line. But for that to work, you'll first need a release build of Godot CPP. I feel like there's probably a lot I forgot to mention, but it's hard to predict what questions people will have. So if there's something else you'd like to know, if something was unclear, or again, if you find any mistakes, please leave a comment. And if it feels like there are enough questions to warrant another video, perhaps I'll make one. So if you'd like to see that and other game development videos, please consider subscribing. Also, it really helps me out if you hit the like button and spread the word about this channel. And as always, thanks for watching.